So we now are at cofunction identities. We have sine theta equals cosine of pi over 2 minus theta. You have tangent of theta, which is equal to cotangent of 2 pi minus theta. We have talked a little bit about this, yes. We have secant of theta, which equals cosecant of 2 pi minus theta. On this side, I have cosine of theta equals sine of pi over 2 minus theta. We have cotangent of theta equals tangent of pi over 2 minus theta. And last but not least, we have cosecant of theta equals secant of pi over 2 minus theta. Okay, after that, we have even and odd identities. We have definitely talked a lot about this. You should be able to fill them all out for the most part, but I will fill them out as well. So you have sine of negative theta equals negative sine of theta. You have, do you need a second, hon? Okay. We have, our next one is cosecant of negative theta equals, is it okay if I leave them down there for now and then on the next slide I try to bring them up every time? Okay. We also have cosine of theta, or negative theta, equals cosine of theta. We have secant of negative theta. I'm sorry?
Why is it not negative?
So it's not negative because if you remember, that's an even function.
Okay.
So when the negative comes out front, those are the ones that are odd.
Okay.
Yep. Next question.
That's what secant and cosine?
Say it one more time. That's the same for both. Yep, because they're reciprocal functions. And then last but not least, we have tangent of negative theta equals negative tan theta. We have cotan of negative theta, which is equal to negative cotan theta. Is that a function is even? So a function, remember we abbreviate function as fxn, is even if f of negative x equals f of x. Ooh, that went downhill. Okay, and it is odd if we have f of negative x equals negative f of x. So remember when we tested functions, we put in that negative x, saw what it returned. Question, we want to find cosine of x minus pi over 2 if we know that sine of x equals negative 0.3 or 0.37. I scrolled too far. I wish I could scroll easier.
No, there's an example for it, a question.
You have 4 on there for it.
Yeah, because the 4 with it says examples, what we're doing in class, the 4 that is just the number 4, that's what you guys are doing for homework.
Yeah.
I'm just going to go over here and scroll. Here we go. Okay, so you should be at example 4. Are you there?
Yes. Can we ask you a question?
Now that you have found the identity we're using, does that look like the cosine we have? So what's different? Yep. So how do we fix that? Sure you do. You can pull out a -1. We factor out a -1. It rearranges our equation. So if I have sine x equals cosine of negative pi over 2
What we do to them?
minus pi. I'm sorry, can you say it again?
Yeah, negative before
We're
the
doing
pi.
that to rearrange the part in our parentheses, so our argument of our trig function, to be in the same order as the identity.
Okay, so we're gonna have a negative. We're gonna have a negative pi over 2 and
So
a
we pulled
positive
that-
theta.
So now we're pulling out the negative because it's already like that. Yep. Even function, which means that it's equal to cosine of 2 pi minus pi over 2 minus x. We have our value in this case of our sine. What is our sine value? So we know that negative 0.37 equals cosine of pi over 2 minus x, which came from the beginning of cosine of x minus pi over 2. Beginning here, I like to have mine as 1 over cosine of x over 1 minus sine squared of x. When you are looking at this, what do you notice? There's a 1 over the cosine, which could change to? No, reciprocal function. It could change to secant, and that's a possibility. We could work that way, but there's something else we could notice.
The square.
So there's something bigger that comes with the square. So what identity, which identity deals with the square of sine?
That was yesterday.
Yep, I gave it to you yesterday. When you see this, 1 minus sine squared Right then.
Sine squared theta plus cosine
equals
1.
So if you rearrange that so that you have sine 1 minus sine squared theta, what are you left with? So Kennedy found our identity. You had the identity of sine squared theta plus cosine
Squared theta.
equals 1.
Yes.
I want to get my sine squared to the other side, so I have 1 minus sine squared. So I'm now going to have cosine squared of theta equals 1 minus sine squared of theta. Same identity, just rearranged. If you saw this without rearranging it, you don't have to show me that you knew this. It's something that I know that you should know when we get to the test. Now that I have that, I can now substitute it in. We see we have 1 over cosine of x times cosine, oops, yep, thanks, cosine squared of x. So we rearranged our Pythagorean identity to get it in terms of what we had in our problem. Now that I have it in terms of that, I can now swap it out, direct substitution, in here. I now have cosine in the numerator, 2 cosines in the numerator, 1 cosine in the denominator. I can cancel one of the cosines out. I'm left with just cosine. You're left with just cosine.
Cosine.
You know what?
You're trying. I appreciate effort.
Right.
You're left with just cosine.
Why did you just live with cosine?
Cosine of x, yep.
See, Miss Jiggy, you got me confused.
Which part? Okay, so we know this identity. We just used it.
Oh, let's go.
Sine squared x plus cosine squared
Hey.
x equals 1. I want to create the 1 minus sine. I didn't have to rework this because we did it on the last page. That gives me cosine squared x equals 1 minus sine squared x. I now have a direct substitution I can perform, which allows me to now have cosine squared x over cosine of x. And we see, just like Giselle did, that we're now just left at cosine x.
That's crazy.
Simon, you found it?
Yeah.
Nope.
Tan squared theta plus 1 equals sec theta.
Okay, so right now we want to see if we can turn that negative secant x minus tangent squared of secant x into tangent squared plus 1. So if we factor out a negative secant, I'm left with 1 plus tangent squared. So that worked out nicely.
Okay.
I did this in like 4 steps, but this is a lot quicker. Okay?
Can you repeat that?
Sometimes.
Yep.
That was my idea.
So I now have negative secant x over here. This now is the same identity as up there. I have secant squared of x. Why did we do what, Kennedy? Because we're not done. We have to get it into the simplest form. You look at that, you say that is not simple. We want simple. So we can now multiply these together.
Isn't simple.
Oh wait, so the
That's
tangent
like
square
three,
x
yeah.
plus 1 is secant.
That's it.
So when we are here, you see that we have 2 fractions. One has a denominator of 1 plus sine x. One has a denominator of cosine x. Do you see any other identities that we could get off the top of your head?
None of these are helping. No.
I'll tell you, none of them help me either. So when you have 2 fractions, how do you add them together? You need to get what?
Denominator.
Common denominator. So we are going to multiply our first fraction by what?
Cosine x.
Cosine x over cosine x.
Yeah. And the other one.
Hold on, give me 1 second. Let me write this, and then Kennedy, you can tell me. So the other one you multiplied by
1 plus sine x.
1. Ooh, not just plus sign. 1 plus sine x over 1 plus sine x. Okay. When we're here, we now have cosine squared on the numerator. And then you ended up with cosine x, parentheses, 1 plus sine x in our denominator. Let's make that bigger. Plus, when I multiply that out, you're back to foiling. When you foiled,
Oh no.
what did you get?
The front, outer, inner, something.
Is that just double distributed?
Yep, double distributed
Yes,
property.
Kennedy.
First, outer, inner, last.
Yes.
I have a question. Why don't the x is squared?
Why?
So, you see a cosine squared? We have cosine squared x plus sine squared x. Do you see what's happening? Plus 1 plus 2 sine x all over cosine x 1 plus sine x.
Yeah.
I rewrote the whole thing because I wanted you to see something beautiful occurred.
I'll see it later.
Yeah.
No.
It's right there.
Oh.
We have 1 plus 2 sine of x all over cosine x 1 plus sine of x, which gives me, you did not have to show that step. You could have just gone to 2 sine of x all over cosine of x 1 plus sine of x. You see you have something in common in our numerator. What can I factor out? 2. We end up with 1 plus sine x all over cosine x of 1 plus sine of x. Numerator and denominator both have the exact same thing. I can cancel them out. I now have 2 over cosine of x equals,
Am I done?
we're not done because we can rewrite that so that we don't have a fraction. How do we make that where it doesn't have a fraction?
By the reciprocal.
Well, we're not going to multiply by the reciprocal
What the heck? I don't know.
because we don't have an equation. You guys started with an expression. How do we rewrite 1 over cosine? Reciprocal identities. Yep.